Alrighty. Hello everybody and welcome to the stream. I hope everybody's doing well tonight. Tonight we're going to pick up where we left off, of course, with our big refactor effort. I have done some work off camera, so we'll quickly go over that. And then we will continue. Before I jump into too much of that, though, I do just want to take a quick second and thank the supporters of the channel, beginning with our partners who are the highest tier of subscription over on YouTube memberships and Patreon. They are Dustin Punt, Gabby Bashir, and Gabroles Inc. I would also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. I greatly appreciate it. It helps me grow their channel, so thank you for that. And of course, I hope it goes without saying that I appreciate each and every one of you viewers, whether you're here on the Twitch side or you're here on the YouTube side. We do simulcast to both. And so I do keep an eye on both chats. And that being said, this is an interactive stream. So if you guys have any questions, comments, anything you want to chat about, as long as it's loosely related to what we're doing here on the stream, feel free to jump in, say hi, and I will respond to the best of my ability. So that being said, RCW, good to see you. Eyeless42, good evening as well. Welcome to the stream. All right, so last time where we left off was we were in the middle of hooking up dynamic rendering in Vulkan. And we got about, I want to say like 90 or 95% of the way through that. And basically what we had to do was basically just hook up the plumbing from the renderer front end to feed into that back end. And so all that's been done offline. And so essentially what we have now is on the renderer front end, we have this renderer begin rendering, and then we also have down here we have renderer end rendering, right? That passes through to the back end, and then that executes all of the logic that we saw in the last stream. We'll just take a quick second just to review all of that as well. I do believe there was a bit of that we hadn't covered on the last stream, so we'll kind of quickly step through that. So before we jump into that bit, though, we do a little bit of processing here on the front end. So we essentially say, okay, well, if we have one color attachment, we are essentially going to pass that through to the back end call, right? Whoops. And so, here we go. Hit the wrong button there. So, if we have a single color render target, we essentially just pass the address of through it, right? If we have more than one of those, then we actually use our frame data's frame allocator to allocate a new array for those attachments, and we create an array of those attachments and pass them through to the back end. So there's not a crazy amount of things going on here, just a little bit of dynamic allocation, but it's using our frame allocator, which, if you recall, is a linear allocator, so it's super fast, right? Because there's minimal overhead there. So if we have to do that, it's not a big deal. We just go ahead and do that. But in most cases, we're not going to be doing that, which is why I have this sort of special case here for a single color attachment. So we take that. We also take into account the depth attachment, and then we pass all of that through to begin rendering. So we pass along the back end, of course, the frame data, the color target count here, the color data, which is that array, and then also the depth data, right? So that's just the sort of the internal texture data that's there, right? That texture internal data that we're passing through there. And so that is essentially what happens on the front end. And then really quickly, in the Vulkan backend, if we go to begin rendering, we essentially use that information to fill out the structure that we need to fill out to call the VK command begin rendering, or the dynamically loaded KHR extension version of that, depending on which one we have loaded. So we covered that last time. And essentially the way that we do this is we take in all the data that was passed here. We grab the command buffer, that kind of stuff, standard stuff we've seen before. We grab the active viewport. We use that to fill out the render area. We also are assuming one layer count here, which may or may not change. We'll have to investigate if that works. I suspect there may be some issues if we like render to a cube map or something like that. So we may have to revisit this. In fact, this may be a problem for layered images cube maps. Pretty confident that's going to be a problem, right? So we can actually derive that information from the attachments themselves. We'll just have to figure that out. So if we have a depth stencil target attached, we go ahead and fill out the view information for that and the depth and stencil attachment. Otherwise, those are zeroed. And then if we have a color target count, right, because it's possible that we only do depth or stencil. If we have that, then we set up an array here of rendering attachment info for the color attachments, which again, we're using our frame allocator for that, right? So it's kind of a repeat of what we see on the front end, except this time we're doing it with our Vulkan structures, right? And then we just loop through those, create the data as necessary, and then fill in the P color attachments, right? And then we call our VK command begin rendering here, and that is really it, right? And then end rendering is basically super simple, right? So all it requires is just a command buffer, right? So we just call either this one if we're using it natively, or we call this guy down here if we're using the extension, right? And so that's kind of where we left off last time. And this time we're going to handle something a little bit different in terms of one of the other things that we've been needing to refactor for quite a while that fits in with all of this other stuff. All right, so before I jump into that, Willager, good to see you. Sergeant Pepper, good to see you as well. Welcome. Ali Mickey, hello as well. Mr. Mean Mr. Mustard, rather. Got that backwards. Hello over on the YouTube side. I hope you're doing well. All right, so what we are tackling this time around is we've gone back to our forward render graph node, and we had a note up here that said, you know, we need to refactor all of this stuff in the execute, and that's actually what we're doing. And I've got partially through that, and so I'll kind of briefly explain what we're doing there, and then we'll kind of pick that up and see if we can't finish that off tonight. We may have to touch some of the other nodes as well, but this is by far the most complex one. So that's kind of the goal for tonight, as it were. Let's see. You're not the only one with a Beatles inspired nickname. Hello, Sergeant Pepper. That's awesome. I love it. Guy CH14. Hello. First time chat. Welcome. Welcome to the stream. All right, so what we've done is, if we recall where we were at before, this begin rendering used to have a render pass here. We don't have render passes anymore. So we've taken that call to render passes out and replaced it with that renderer begin rendering, right? So we pass through the renderer state, and then we pass through the P frame data, number of color attachments, the color attachment itself, which in this case is just the color buffer texture, render texture handle, and then we pass through the depth buffer handle as well, right? So we do all that for begin rendering. If you recall, that is return type void, so there's nothing really to check here, right? It's just a Vulkan command. And this is essentially what replaces our render pass, right? So essentially what we're saying here is we want to begin rendering to the attachments that we've provided here, more or less. This interface may or may not change. I'm not 100% sold on it yet, but for right now, it's what we're going to roll with, right? Let's see. Is it okay to develop for Windows on Linux? I mean, you can, but it might be tricky to test, right? Unless you have a VM or something. But yeah, you definitely could do it. I usually do Linux development on Linux and Windows development on Windows. But you could certainly mix that up if you wanted to. Sergeant Pepper, you love to hear it. Awesome. Yeah, I figured you would like that. Currently working on diffuse lighting for my renderer right now. Nice. Nice, nice, nice. Good stuff. All right, so the next thing that we have worked through is we've reworked the Shadow Cascade directional light logic a little bit. So we actually have, in our state, we have the directional light views and projections, which we can set in a function. But then we also have these light spaces, which are basically just these two guys multiplied. So the way that this works is as our scene is sort of being processed, we will set the light views and projections, and then when we go to execute the pass, we'll actually perform these multiplications there, right? And so that's kind of the way that works. That's what this is doing here, is it's just multiplying those things and getting these directional light spaces ready for the sort of next step of this. So just as a recap for our forward render graph node execution, we handle terrain geometries first. So terrain geometries are essentially our what do we call them? Chunks of terrain, right? So our terrain is sort of chunked up into these, I think, 16 by 16 space intervals, right? And each one of those is essentially its own geometry, and we render those things separately so that we can cull it and stuff like that. So that's what this is rendering. And in order to do that, we say, well, first, if we have any geometry to render, then that's the first thing that we do is check that, right? Because if we don't check it, we can skip it. So if we have that, we go ahead and we use the shader for that. We set the wireframe state, right? So if we are currently, if our current render mode is in wireframe, we will use the correct pipeline under the hood. And then we will apply our globals, right? So our global uniforms. Let me just move this over a little bit so we can kind of see this a little bit better. So this whole section right here is essentially what was in the material system, right? And we've actually stripped that out of the material system and moved it into here. Now, you might be wondering why. Why would we do that? That is because we wrote the material system before we actually had views or render graph nodes or any of that stuff, right? And so the material system was kind of responsible for not only managing the materials themselves, managing the creation and destruction of those things, but also applying the attributes of that into uniforms and things like that. And the material system really shouldn't be responsible for that, right? It was something that we did initially because we didn't have anywhere else to really put it. But now we do have a place that should be managing that, and the render graph node is what should be managing that kind of thing. So what we're going to do is we're essentially going to go through our material system and remove anything that has anything to do whatsoever with shaders. Or sending anything to the GPU, and we're going to take all of that out of the material system. So the idea behind the material system is it's just going to manage materials and the properties of those materials, updating them, so forth. And then in terms of actually applying those to the GPU, we're going to leave that up to whatever render graph node is actually using that to do that. Separation concerns, it's pretty important. And it's something that's been kind of a long-standing thing that I've said several times on stream. We need to actually get these out of here, right? And so I've done that here. I started this. I basically commented this out, right? And I took all this stuff and moved it over here. And I then went in here and just put a fatal message here, right? So we should not be calling apply global for terrains anymore, right? And the reason I've done it this way is so I can keep track of what I've moved and haven't moved. So we have our globals that has got that logic moved over for terrains. And then we have each terrain chunk here, right? And our terrain chunk has instance data that has to be applied. And I've gone ahead and moved the instance data for those terrain geometries as well. So that has been moved over. And I've also moved over the locals, right? So I've moved all of this stuff out of the material system and into this render graph node, because that's really where it belongs, right? And of course, the draw call was always kind of here. So what we need to do now is replicate this for our static geometry calls, right? For all the stuff that static geometries do. And we'll kind of see where all the changes have to be made, right? So we still see here that we're saying material system apply global. Like this is going to get replaced with all of the global stuff that is over here. Down here, right? So all of this is going to get moved over, right? And that's basically what we're going to do. And then once we've moved everything from the material system, we're going to strip those functions completely out of the material system, and those concerns will be separated. So that's basically the gist of what we're looking to do tonight. Tammin, good to see you. I am doing well. How about you? Hope you're doing good. It's always good to see you on the stream. Welcome, welcome. Let's see. Finally, a video I clicked that didn't start a commercial. Yeah, I get that. Yeah, we do actually run ads on here. So we do simulcast to Twitch and YouTube. And so I do pause the stream whenever Twitch ads come up, which is once every half an hour. So you'll see an ad screen pop up here where I pause the stream so that nobody misses anything, right? And I think I can manually trigger YouTube ads, but it works a little bit differently on that side. So I'm not 100% sure. I'm still trying to kind of figure that out. But that's more or less what we're doing, right? Let's see. How to work with this from Brazil. We only have back-end jobs. So what do you mean, Dorito? Or wait, no, that's not Dorito. I completely mispronounced that. Sorry. Doido. My brain just put an R in there for some reason. So are you saying, how do you get into game development in Brazil? I know there's some folks over on the Twitch side that might be able to help you with that, because we actually have a decent Brazilian following here. I think like 15 or 20% of the channel's followers are actually Brazilian. So you may want to hop over to the Twitch side and chat with the folks there for sure about that. Singy, how's it going? Good to see you. Let's see. After finishing the refactor, will you add a new feature or start your first game? Sometimes there are ads on YouTube when there's ads on Twitch. Yes, I try to trigger them at the same time, and I think I have that down, but we'll see. So to answer your question, after finishing the refactor, I don't think there's actually much that we need to do before we can start the first game, right? What I suspect is going to happen is we're going to start to sort of, start scaffolding a game project. And then we're going to say, oh, crap, we need to change this about the engine. And, we'll be bouncing back and forth. But, yeah, I think we're getting really close to the point of starting the first game. This big refactor is a decent-sized portion of that. And I think there's some stuff that we can actually skip. So if we look at the to-do... So this is part of the refactor. I've got a bunch of things in here for the refactor that we have to do. So everything to version 7, 0.7 is up to here. So this all pretty much needs to be done. A lot of this is already in progress. Let's see. So I think a lot of this can actually wait until we actually start creating the game, right? We may wind up doing some of this, but I've got some items in here I think that could probably wait. We don't really need... We're not going to be implementing any other backends for the first game. It's just going to be Vulkan for the first game, which I think is fine. And the first game's not going to be terribly complicated with how much geometry we have, so I'm not even going to have to do things like batch rendering and stuff like that for the first game, I don't think. So I think we have like most of what we need. We even have sound, right? So UI, it's going to have a custom UI, so we don't really even need the standard UI for the first one. We don't need the editor for the first game. So yeah, I think, oh, this is actually, that's actually done. Okay. So yeah, there's not too much we have to do, right? We're actually going to start creating the game, I think, right on the tail of this refactor. I don't think there's a whole lot we need to do other than that. So, wouldn't geometry generation be useful for a simple arcade game? Yes. So that is something that we might do. We already have some of that stuff in here. Where was that? Yeah, so we already have some of this 2D and 3D, right? We have a cube, we have a plane. Do I have a cylinder? I think I did a cylinder, or if not, I've got it around on a branch somewhere. I forget. So we may deal a little bit with some geometry generation just for like a simple arcade game. You might be right on that. I might do that, or I might just use OBJs for it, frankly. We'll see where we wind up like that, for that. It may be easier to just use OBJs. I don't even think, depending on how we do this first game, I don't even think we're going to need skeletal animation. I think we can actually get away without doing that. So, let's see. Estrobico, thank you for the follow. Appreciate that. You're also refactoring your renderer, Tamron? That's, yeah. Yeah, another Brazilian mentioned. Brazil mentioned, yep. Use Brave water ads. Yeah, that's fair. Brazil is always mentioned on this channel. Yeah, 100%. There's a large Brazilian following here for sure. Tamandua is the OG. The OG Brazilian on the stream, for sure. Guy CH14, thank you so much for the Prime. I appreciate the support there. Thank you very much. All right. Yeah, Tamandua is definitely the OG here. Mr. Anteater in a suit. All right. So where we are is we basically have to remove the shader application logic from the material system. It should be here. That's what we're doing. This is the only location that calls this anyway. So what I'm talking about here is the apply global, and then the apply instance. Like this is the only place in the code base that actually calls this, right? So it's pretty safe to pick this out of here, plop it here, and then we'll be good to go. There's an aged AI-generated singer that is supposed to be Brazilian but sings in Hebrew. That's funny. That's very funny. All right. So let's get rid of this. Actually, before we get rid of that, let's go over here and actually just rip out all of this logic. So this is our global logic. So I'll copy this over here and paste here. And we'll do, I'm going to scope this just to make it a little bit easier to see what is going on. Right. That to do is meaningless now. So I'll take all of these, and we actually have a different version of this called uniform apply or fail. And just so we can see what that is, this uniform apply or fail is basically just a macro that makes things a little bit easier for us. So it checks that the return value of that is true, and if it's not, it throws an error saying it was trying to apply the uniform, spits out the code where it was trying to do that, and then returns false, right? That's just so that we don't have to repeat that again and again here. So shader system uniform set by location. Let's see. We have the projection, view, ambient color, view position, and render mode. So those, we can actually use the same logic that we had up here for that, which is actually, I'm actually just going to copy this real quick, minus the cascade splits. And let's see, where was that? And we'll just put it here. And let me just move this over a little bit. So we have projection, view. Oh, we did have cascade splits. Okay. All right, this one I think should just be the address of internal data cascade splits, I think is what that one was. All right. So we have all of those. Light space for shadow mapping. All right, so we loop through all of our cascades here. This is going to be internal data. And then directional light spaces is what we called that one. Global shader options, this is use PCF. And this should be, I think it was just use PCF, wasn't it? What did we do? What did we do up here? I forget. Oh, we obtained it from here. That's another change that I made off camera we should probably review really quickly. So let's put this here. Okay, use PCF. All right, so if you recall from when we put in PCF filtering for the shadow maps, that was actually tracked by the material system. We have moved that to the renderer. So the renderer is now responsible for holding onto that and what is responsible for giving us that state. It also listens to the messages. So that was one of the things that we could actually adjust in the console, in the developer console. And so that has all been moved to the renderer. And now we can actually just call the renderer and say, hey, what is this current value for this thing? Okay, so that's that. Now the only thing here is we still don't have something there for the bias, so I've left that hack tag in there. That's the shadow map bias, right? But that should be relatively it, right? So if we go over here to our material system apply global, right? We will kill this section, right? And so the top section was checking to see if it was the terrain shader ID. This one is checking for the PBR shader ID. Both of those are dead now. This is an error condition if it's something else. And then we have this apply or fail, right? Which is for the global update on that, right? So that we can actually pull from up here as well, which is going to be, let's see. Did we? Right here. All right. So we can come down here, right here at the end, right? And we can apply that, right? And that's going to do it for the globals, right? So we're about to have ads here, but basically what this means is this whole function here for applying global, gone. Don't need it anymore. All right, looks like we're about to have ads here in just a second, so I'll just quickly explain. We do like to pause the stream whenever ads come up on the Twitch side, which is once every 30 minutes for up to 90 seconds, depending on region or locale. To keep the playing field even, I like to pause the stream for everybody so that nobody misses anything, simply because, you know, you can't understand what's going on in a programming stream with a full screen ad playing. So we like to pause that. I put a timer on the screen so you guys know exactly how much time we have until we come back. I usually say, you know, go ahead and hydrate during that time. If you got to get up and walk away for a minute to get some water or something, go ahead and do that. And we now have ads. So there is the timer, and I will trigger ads on the YouTube side as well. All right, so we've got about a minute left on ads, and then we'll get back to it. Lear Code, thank you for the follow. Appreciate that. So we got about 30 seconds left on ads, and then we'll continue. Almost done with ads. All right, and ads are dead. Lear Code, thank you for the follow. First time chat. Hello, I'm new. Can I question something? Question away, as long as it's related to the stream, right? Ask away, and I will answer whenever you put that in there, probably in a couple minutes. All right, so this is our globals. So what we're going to do is we're just going to take away all of this old stuff because we no longer need that. And that's our global uniform application there. Let's also quickly go over to the material system H. And where we have material system apply global, we're going to nuke that because that is no longer needed. All right. So the next thing to do is the instance stuff, right? Which is all of, I'll scroll this up a little bit so you guys can see past my noggin. It's basically all of this stuff, right? So all of that instance stuff is going to be in here. So here is where we go through our geometry count. We figure out how many geometries we have to draw. And here is actually where we're loading material for it. I'm going to clean this up a little bit. And what we're going to do is instead of ext data geometries, this is going to be internal data geometries, right? And what we're going to do is we're going to take this value, or this bit here, and we're going to replace this 0 with that, right? That's a material pointer. Yep, okay. So we're going to start off by assigning this, right? And this could potentially be a null pointer. So we're going to say if not m, then we'll use the default, right? So it's just a little bit cleaner. And then we will say only rebind, update the material if it's a new material. What was the rest of that? Duplicates can reuse the already bound material. Okay, so this is basically just this a little bit of an optimization to say, well, if the material hasn't changed from the current material ID, which is up here, then we go ahead and bind the new material, right? And so essentially what we do here, this is another change that we have actually made. So we had several places in the renderer front end, as well as in the material system and in the render graph, where we were trying to determine if we needed an update, right? And so the material had like this frame number tracker that it used, and then it tried to grab the renderer frame number from the p-frame data, and then we also had this draw index. All that stuff is gone now. And so what we've done is, I'll take a quick second here to go to the Vulkan backend. And what we've done is we've actually completely done away with all of the needs update checks. Whether you were doing globals, whether you're doing instance, whether you're doing locals, all of that basically boiled down to this function right here where we're updating the descriptor sets. So updates and bind. Let's see. Okay. So ultimately, this function right here was what that was all needed for, that needs update. We no longer do that. Instead, what we do is we pass through the renderer frame number, which is now tracked in the renderer front end, right? So we just pass this through. And within the descriptor set state, we actually track the frame number, right? And so what that gives us is a way in the Vulkan backend to say, do we need to update this or not? And it keeps us from having to not only determine that in user code or in the renderer front end, but it allows us to solely have that happening in the render backend, which is the thing that really needed to know whether or not that was true. So instead of doing all this calculation of all this kind of stuff on the front end and passing that through to the renderer front end and then passing it through the renderer back end and then passing that through to this function, we essentially just pass through the renderer frame number and then check it out at this level. So if we scroll this up a little bit, the needs update is now calculated here, right? And that is basically by saying, take the descriptor state that we're passed in, look at the frame number for the given image index, and say, is that equal to or not of the renderer frame number? If there's a mismatch here, then it needs an update, otherwise it doesn't. So what this means is when we say we need an update, do we have to write to the descriptor set, yes or no? If we do, then we go ahead and we set up a descriptor write with all the buffer info, all that kind of stuff. If we don't have to actually do that, right? So it's already been updated for that particular frame. Then essentially what that means is we come all the way down here to the bottom, right? This is the end of that if check, right? So all the way down here to the bottom. And we say, just pick the correct pipeline, grab the command buffer, and bind the descriptor set, and you're done, right? So it's a major optimization to not have to, but it's also, it's a lot cleaner code so that we don't have to figure that stuff out in user code. We could just leave that in the renderer backend, which is all that needed to know that anyway. So I hope that makes sense. That was another change that I've been wanting to make for a while. So all that to say that, let's see. I think this entire comment can go. Yep, this entire comment can go. We don't need it anymore. Which also means we don't need stuff like this render frame number or render draw index, right? Which both been removed out of the material structure anyway, right? So that's all gone. So basically, all we have to do now is go to our material system, where our apply instance is, and we will grab all of this right up to here. Go over here, highlight this, slam it in there, right? PBR shader, that's kind of redundant. And then we can do, this will be uniform, apply or fail. And so we can just apply this to all of these, right? And then we got a couple more here, right? And then we update the current material ID. So update the current material ID, right? And then one other thing we need to take from here, and I'm actually going to comment this out so it's very obvious what we've done. We don't care about the terrain shader anymore, but we do care about this last little line down here. So this guy needs to be moved over here as well, and needs to go right here. Right, so 8 substitute uniform, right? And then the shader system apply instance no longer needs the update. I think all it needs is actually the shader itself. So we're gonna have to take a look at some of these functions. A lot of them are gonna need adjustments, but that is more or less the logic pattern that we have to follow. So what that means is over here on the material instance side, we can select that whole chunk of code and nuke it, right? And so from there, we can go to material system H, and this material system apply instance, gone. All right. The last one is this apply local, which is going to be really quick because it's pretty small. So we'll just knock that out really quickly too. So it's basically going to replace this material system apply local. So all we need to do here is, let's see. We need this, this one line. So I'm going to paste it down here. We're going to say B8 result, right? And then for model here, we are actually going to pass, this is internal data, right? We're going to pass this there, right? And then we can remove that. I feel like there was more to that. Oh, there is. One more thing. Shader system apply local. Has to also be called. Right? So I guess we can also scope this. Just to make it a little bit cleaner. I feel like we're missing a step there. Apply the locals. Oh, shader system bind local, I think, is a relic of the past. That does not exist anymore. That's what we were missing, but we no longer need it. Okay. So, uniform applier fail. We should probably use that here. Right? So, uniform apply or fail. We'll wrap that in there. And then apply local. That should be it in terms of what we need to do for this one. So let's see, we don't have anything else out here. So we are just going to take this, nuke it. I don't think we need the supplier fail anymore either. So that can go bye-bye. Material system H, we can remove. Am I behind my own head here? No, okay. We can get rid of this guy. Apply local, right? And so we can see here that we've cut down the number of lines or the amount of functions we have here quite a bit. So now this is, I think, almost exclusively dealing with actual loading of materials themselves, default materials, things like that. But it does not actually handle anything in terms of setting shader properties or anything like that, right? This shadow map set and irradiance set and light space set, those are no longer relevant either. Those have also been taken out of there. Don't need those anymore. Okay. So I think we're done with the material editor for now. Or the material system. I believe we're done with that for now. So I'm going to close that buffer so that we can focus on this guy. Let me just catch up on chat really quickly. Your color theme is so slick. Going to try to replicate. So this is the Adwaita color scheme. And then my terminal actually uses the GitHub Dark on top of that. So it's kind of a combination of those two things. I believe I have all of that in this article. I'll link here. Yeah. I'll toss that over on the YouTube side too, so you guys have that. Let's see. Nothing to see over on the YouTube. I can barely read your name, by the way. That's some crazy UTF-8 stuff you have going on in your name. But hello. Is the refactoring still going? Yes, but we are in a completely different section now. So we are working on taking some of the rendering logic out of the material system and moving it into the render graph node. Because when we created the material system, we didn't have the render graph, right? So the material system was really kind of doing both the rendering and management of materials themselves, which isn't right. Okay. So, we've obviously got a crap ton of errors in this file. So we're going to have to see. We're going to have to start like looking at these things and fixing them. This was the other bit that the material system was doing, was actually holding all of these locations, the shader locations for the uniforms, which we don't need to do that anymore. So let's see. What are we missing here? Okay. So a lot of these shader system functions used to take pointers to shaders, but now they just take shader IDs because it's a lot easier to keep these IDs all over the place than pointers, right? And these are kind of like a little bit like handles, but again, this was developed before we actually had handles. So our shader system doesn't have handles, but we do have IDs, which are a close second, right? So we use that to do an internal lookup to get a shader, and then we do the thing. So a lot of these have actually PBR shader. Technically what we need is that, right? The ID. However, this, like all these indirections, just call that every single time kind of sucks. So I think I'm going to save off the PBR shader ID separately. Let's see. So we'll peak definition on this. Right, so we're storing pointer to the PBR shader here, pointer to the terrain shader, pointer to the color shader, and then our locations here. So I guess what we'll do is, I'm not actually sure we're going to need the shader pointer for anything after this, but we'll say U32 PBR shader ID, and we'll do U32 terrain shader ID and U32. Whoops, U32 color shader ID, right? And I know that we're gonna be moving the color shader, right? But we're not there yet. So now we can just do PBR shader ID, right? So now we can just basically, oops, if I can paste in the right location, I guess I could just, probably be faster to just do it that way, right? Oops. Right, so we're just going to use the ID on all of these guys instead. All right, so we've got that. So this is just where we're grabbing all of our uniform locations. We do that for that, and we also do that for the terrain shader. So this is going to be terrain shader ID. All right, so we need to just all right. So that's all of our shader locations. Now what's it bleating about? Let's see. Oh, this is probably going to be the same thing. So it's just going to need, there's only 3 of these ones. So I'm just going to do that. All right. So, oh, you know what? It looks like we were using pointers to shaders in a lot of places. We should not have been. So we should be using these IDs all over the place. Again, this is kind of antiquated logic that we had in here. I suppose. Nah, I don't want to do a find and replace. That seems a little bit dangerous. Okay, so shader system uniform set by location. What does this need? It needs the shader ID first. Okay, so we also used to have this this concept of sort of binding a shader, right? So whenever we used a shader, we were also maintaining that state in the actual shader system, and we're no longer doing that. So we are going to require that any of these uniforms set by whatever, or anything that modifies a shader needs to take in the ID of the shader that it's modifying, right? So what that means is we essentially have to say internal data, and this is going to be the terrain shader ID, comma, right? To solve that, internal data, terrain shader ID. So we're probably going to have to do that a few times here. Right. So that's those. And then the shader system apply global. also just needs the shader ID, right? So it no longer needs p-frame data. It needs internal data terrain shader ID, right? And so that eliminates that bunch of errors, and then we're basically going to have to do the same thing for this guy here. So we have material shader system by instance, rather. And this should be shader ID and instance ID. So we need the internal data, and this one is for the PBR shader ID, right? So we're dealing with the PBR shader here. Oh, wait a minute. No, we're not. I lied. We're still in the terrain shader. Right? So we're going to have to do internal data, terrain shader ID, comma. And one right there, one right there. We've got a few more. Let's see, right here, right here, and then instead of p-frame data, we use terrain shader ID. And then apply locals is just going to be a single, well, I guess two changes: internal data, terrain shader ID, comma, and just that by itself there, right? So those should all be fixed now. Let's see. What plugin do you have that allows you to highlight text and get a preview of its implementation? I can't see it in your setup. So that's a combination of, I think it's Tree Sitter that does that, or maybe it's Telescope, and the LSP that provides that information. So the LSP is what says pop up the window, and then it's either Tree Sitter or, actually I don't think it's Tree Sitter, I think it's Telescope that does that. Let's see. Validation layers would throw errors if I'm using VK command bind vertex buffers incorrectly, right? Yes. In most cases, anyway. You forgot to set binding count to 2. Yeah, that would do it, right? Let's see. Max, good to see you over on the YouTube side. Implemented shadow mapping for point lights this week. Stoked that it's working. Awesome. I still actually have to do that. That's on my to-do list. I might actually have to do that after this refactor before we do a game. If I use a lot of point lights, I'm probably going to have to do that. Maybe all these internal data stuff can be managed with some sort of macros. I mean, maybe. The problem is like the internal data stuff kind of varies by what I'm doing, right? Are you talking about like where I have to say internal data terrain shader ID? Like I could create a local variable that just is like terrain shader ID, and I suppose that would be a little bit more concise, right? I just figured using internal data has kind of made it explicit where it's coming from. But yeah, it's a little bit verbose. I agree with that. Oh yeah, does point light store a handle to its shadow map texture? So there are a couple ways you could do that. When I go to do... So right now, the way that I have it is for the directional light, that's actually stored in the shadow map pass. And I think the way that I'm going to do it for point lights is my render graph node for the point lights is going to store a finite number of those maps, right? So I'm going to say I'm going to have like a maximum amount of lights that I support. And whatever lights those are can cycle in and out. Like, let me, you know what? I'll show you what I was thinking as far as that goes. So in here, let me move off to the side here. So let's say, for example, you have a scene where you've got, just point lights all over the place, right? I'm just going to kind of randomly space them around, right? And let's say for argument's sake, let's see how many do we have here. Let me simplify the example. Let's say, for example, I'm going to say we can only have ads. Dang it, bad timing on ads. I will finish this thought up when ads finish. And yeah, and then we'll move on. But I've got a semi-clever way of handling this, I think. At least for forward rendering purposes. L ads, yep. Yep. Bezos has got to make his share, right? So we got about 30 seconds left, and then we'll be able to pick back up. Almost done with ads. Okay, so the question was, when you're dealing with point light shadows, does a point light store a handle to its shadow map texture? So let's say you've got a scene in here like this, right? I've got 5 lights here. But let's say, for example, you want to say, you know what, I only want to show 3 dynamic lights at a time. Now, generally speaking, this would be a much higher number. It'd be like 10, which is what Kohi is going to have. Where you can sort of display 10 at a time, or in this case, we'll say 3, right? So that means at any one point, 3 of these will be lit in the scene, and 2 of them won't, right? And I would base that based off of, wherever your player position is, right? So if your player position is here, you're closest to these 3, then these 3 would be the ones that get used. If you were to move like here, then this one would shut off, and then this one would come on, right? And so essentially, you would swap them out in a manner like that. And then in your render graph node, you would actually have a collection of 3 textures that would be used for your maximum amount of lights that you have. And what I would do is pass in an array of these lights to be processed in terms of creating the shadows for that. And whatever 3 you pass, it just uses those textures in that order from that particular point, right? And so the list of lights that you choose can be different and can swap even per frame, but you're not having to create tons of shadow map textures, and you're not having to like stand them up and shut them down and all that other stuff. You're literally saying, give me a subset of however many lights I have, and that's how many lights I will generate the shadow map for, and then go from there. And so that is more or less the way that I would handle it. I wouldn't attach it to the light itself. I would attach it to whatever is responsible for rendering that light, or the light's shadow, more or less, right? So our directional light in Kohi is actually attached to the shadow pass render graph node, right? So I hope that makes sense. I guess while I'm at it, do we group together all static meshes and bake shadow maps for them just once? I guess the lights would have to be static too. So shadow mapping and light mapping is a different topic. So you certainly could do that. We may explore that here at some point. But I don't know, probably not for the first game, right? But yeah, if you're talking about static meshes, then yeah, baked lighting and baked shadows is another way to go. But if you're talking dynamic stuff, this is the way I would go with it. We need shopping channel or elevator music for ads. That's not a bad idea, actually. If I could find something that wouldn't get me DMCA'd, I'd use it for sure. All right. So that is everything for that. We need to convert this stuff over. Right, so this is going to be PBR shader ID. This can also just be PBR shader ID. And then here set by location, we're going to have to, oops, that should be internal data. We're going to have to do this and say internal data PBR shader ID, comma. Okay. So actually internal data, we need to actually swap those out first. Should probably swap a lot of these things out because they're all over the place. The state pointer was what it was referred to in the material system. We don't have that. We don't have that here. We have internal data here. So there are other things here that we're going to have to probably take from the other section, but that's okay. Let's see. So state pointer, that needs to be internal data. That needs to be internal data. Okay. So, oh, this needs to be as well. Okay, so we left off here. Internal data, PBR shader ID, comma. So we got right there, right there. I'm going to skip that one and come back to it. So we want that there, there, and there. Another one here, another one there, there, right there, right there, and right there. Okay, and then this is PBR shader ID, internal data, PBR shader ID. All right, so that should fix all of that. These things down here still have a few small issues. So let's see, shadow texture. Do we have, what did I do up here for shadow maps? Where did I put that? Here we go. Okay, so this is going to be a little bit different for these guys. And I do have a note here that the shadow map should probably be a global uniform, not a instance one for the terrain. Let's see. So let me go ahead and just do this. All right. So the irradiance map, I think, is going to be fine. We just need to change the shader ID on that. Right, so the only other difference is going to be SAMP irradiance map is going to be the array entrance there. Entry, rather, element. So we have the terrain one here. So we need to get rid of that. And rid of that. Same here. And here. All right. Okay. So that replaces these two guys. Now, we need these indices, right? We don't have these guys yet, so let's go to material system. Those are up here. Right, so these samplers, we actually need these. PBR material texture count. I think we need these in both locations, so I'm just going to copy them over here for right now. Close this again. And we're just going to plop these in right here. Right? And now, those should be good to go. Fixed all of these issues. Okay. Alright, so all of those things are fixed. The locals we need to fix up. So that's going to be internal data and internal data, PBR, shader ID. Did we not add that? Yeah, we did not add that here. PBR shader ID. Okay. So that's fixed. Invert if needed. Okay, so this is the winding order. So just to refresh your memory, what this is for is if a geometry is negatively scaled, then we actually have to reverse the winding order of the geometry in order to draw it right side out, right? So we do account for that. Internal data geometries, right? So we do account for that. Internal data, need that, and this should also be that. So what we essentially do is we invert the winding if needed, draw it, and then if it was inverted, set it back. So that's that. Now, the debug geometry is the last part of this, right? And actually, thankfully, this doesn't use the material system, so we don't have anything to extract here. This is just updating the function calls to use the new way of doing things. So a lot of this is going to be changing this stuff over to internal data, for one thing. And then, plugging in the color shader ID to a bunch of things as well. Okay, that did make sense to you, Max. Good. I'm glad that helped. Cool. All right. So we have renderer shader bind globals. We don't do that anymore. That's gone. Shader system set by... Okay, we don't... Oh, we weren't actually checking this stuff. That's great. So we want uniform applier fail. And then we also need internal data, and this is going to be color shader ID. Okay, so debug location is projection, so we set the projection matrix And this is going to be internal data. Projection matrix, I think is what we called it. Yep. And so we've got that. We also have internal data view matrix, and we need internal data color shader ID, and we have uniform apply or fail. Right, so that one is that. Shader system apply global. So I think this one has changed up a little bit because we used to have this needs update, which is no longer there, right? And I think this just requires a shader ID now. So it's going to be internal data color shader ID. And then I believe this returns a Boolean. Yes. So we can say if that fails, failed to apply globals for color shader, turn false, right? And then we have each debug geometry. So there's not a whole heck of a lot here either. In fact, I don't think there's any instance level. Yeah, no instance level uniforms to be set. So this is nice and simple. We don't have the bind local, so we don't bind by scope anymore. All we do is we set the uniforms, and then the uniforms themselves have scope information, so we don't actually have to manage that binding anymore. So all we have to do now is actually pass the shader ID, and then apply or fail on that. This just needs to be internal data color shader ID, and then we'll check this to say, hey, if this fails, let's bleat about it. Failed to apply locals for color shader. Right? So there's that. We do the deprecated geometry call, which is deprecated, not obsolete yet. So we draw that. Now, we do have this frame sync that happens. But we don't actually need it anymore. Right? Because all of our descriptors manage this internally. So if we actually go to this is all the crap that our shader has to manage, FYI, right? So this is all of the data that's inside a single shader. If we do this, so we don't need frame number or draw index, those can go bye-bye, right? So that hack disappears as well. Okay, so rendering rather. Return type void now because it's a Vulkan command, so it can't return false. So we can get rid of the checking on that and just do the thing, right? Okay, so it looks like we missed something here. This has got to be internal data. Okay. So we've got 6 errors left in here. That's a deprecated warning. That's fine. All right. Forward render graph node destroy. Here we go. So we have texture maps and samplers. Why are we releasing the shadow maps here? This doesn't own shadow maps. Oh, wait a minute. This is for the texture map for the shadow maps, though. This is when we go to use the shadow maps. This is when we go to sample them in the shader. Did we actually? So we've got this frame count logic in here again, right? Which is something that we're trying to really get rid of across the board. Render pass destroy, that's not really a thing anymore. So we don't need that. Undeclared X, thank you for the follow. Appreciate that. So I think all this needs to do is just a single shadow map. And that single shadow map will manage the resources internally. Okay, so that's done. Looks like we have a warning down here. So we have internal data, directional light equals light. Right, so I'm guessing it's bleating about the const qualifier. Yeah, it is. I mean, I suppose we could... do that, right? We don't really need to change the light here. In fact, we shouldn't be changing the light in here. We should only be referencing it, right? Okay, so there's that. What next? Our viewport is no longer a pointer in our internal data. But we're passing it in as a pointer. And that's because we are forward declaring the viewport type. So, okay. I'm fine with that. I'm just going to do this. Just dereference it and call it a day. Let's see. We have another warning here. So directional light data. Let me guess. Const again, right? Start. Yes. Okay. So does that mean it wants me to just do this? Yes. Okay. Again, that shouldn't be an issue. So now all we have left is the 3 deprecation warnings. Yep. Okay. So essentially what those are is our renderer front end is no longer going to accept these geometries in draw calls at some point. Instead, what it really wants is like the buffer information, like the offset, the size, that kind of thing, vertex count, index count, all that kind of stuff. Instead of passing a geometry struct like this, because the geometry struct might not always be the same. Whereas we could just pass those pieces of data across, and we can get those from anywhere and do what we need to do, right? So there would be cases where we may not have one of these geometry structs, and we have to basically create one on every frame, and that's poop, right? So instead of doing that, instead of requiring that, we are going to just say use the non-geometry functions, and then these deprecated ones will eventually be removed. All right, let me catch up on ads. On comments. For local versus global uniforms, is global in the context of a particular render pass? How global are we talking? So it is global in terms of update frequency is what we mean there. So for example, when we are rendering a material, right? We have different levels of information. We have global level information, which would be something like your projection matrix, your view matrix, things like that, right? When we are talking about instance level stuff, then we're talking about material instance level. So that means the particular properties of that given material. So it might be like its textures, how shiny it is, etc. That kind of thing, right? Stuff that's specific to that instance of that material, right? And then for locals, we have essentially per drawn object is what you can think. So that means that's basically our model matrix. This is the only thing we really use that for right now. Eventually, when we go to like batch render, that'll probably be the index into an array of matrices, right? But for right now, that's essentially what we're talking when we're talking scope, right? So our shaders have those three scopes. They have global, instance, and local. Let's see. Something I'd love to do. Advice you can take or not. Instead of self and then if self internal data, why not just do if not self or not self internal data return? I do that in some places. I don't know if I do it in here. Oh, you mean this? Yeah. You're talking about this bit. Yeah. So ordinarily, I think what happened was I wrote this first and then I needed to add this, right? So it should really just be that. And then, right? Realistically, it should be that. And see, I did actually convert in some places. Yeah. It's namely because stuff just got added later on and I just never went back and cleaned it up, essentially. In fact, I have that more often in here more often than not. There's just a few places I forgot to actually change. Yeah. Okay. So I think we're actually done with this file. So that's good. Do we have anything left in our material system? We have errors in here. Okay. Okay. So when we are... Let me think. What are we doing here? So this is when we're loading a material. Okay. Material textures. So gather a list of pointers to texture maps, send it off to the renderer to acquire resources. Map count for this type is known. Okay. So when we're setting up our... Why do we need the uniform location for that? Uniform texture config. Oh, I'll bet that's because once we pass this off, we need to get like the offset and that kind of thing for it. So let's see, IBL, cube texture, shadow textures. Material maps. Uniform configs 1. Instance resource config. So let's skip down to the after this one. Okay, so let's take a look at this function. Okay, that's just a pass through to the renderer back end. Shader instance resources require. So we pass through the shader. Okay, so here we go. Texture map resources acquire. Wait, is that the same? Instance resources require. Wrong one. This is the one we want. All right, so we have our config. Nope, we have ads. Woodula, good to have you here. Good night. Have a good one. So we just got about a minute on ads, and then we'll pick up the comments over here on the YouTube side. Got about 20 seconds left on ads. Okay. Ads are dead. Cool. All right. So, global to the scene, I guess. It's not necessarily always global to the scene. It's a little bit more granular than that. So, because think about it, you could technically have a material referenced from different camera locations, right? Like, let's say you had a scene that had a security camera pointing, rendering another part of the scene from a different location, but then rendering it to a texture that you still see in the scene, right? Each one of those would have a different projection matrix, a different view matrix, things like that, right? So it's not quite global to the scene. It's global to the view of the scene. Yeah. Which actually that would technically be a problem if we were to render it that way. Because you can only update those descriptors once per queue execution, essentially. So we would actually have to have a separate set of descriptors if we had a separate thing like that. Yeah, it gets complicated. Summit, hello. How's it going? Welcome to the stream. All right. So we're drilling down here, trying to figure out why we need the why do we need the uniform location? I suppose I could acquire that from the thing itself, right? I don't really have to know. I could just query this from the shader manager, I suppose. It's probably exactly what I'm going to have to do, actually, to get around this. Because we don't have these things in the material manager anymore. We don't have these stored. So I think that's probably what I'm going to have to do. Okay, not a huge deal. All right. So I guess we'll do, let's see, we have the ID. We do. Okay. So let's do shader system uniform location. Let's see, that takes the uniform name. Do I have any way to do this besides name? Because that feels kind of gross, because that's going to break if I actually do this any other way. Right, because if we have material textures and we rename that, then we'll have to rename it both here and we'll have to rename it in the render graph node, which is poop. We don't want to do that. Okay. Is that the only thing that it needs, though? What are some of the other things in here? Okay. Render a shader instance resources release. I think this one requires a pointer to the shader state, or the render system state. Yeah, okay. So that's something that I don't think we have. And that's going to be the same thing here. Okay. Render a frame number, that no longer exists, so that can go away. So it's mostly just a object of these. When we're creating the default materials. So I wonder if we should offload this. Because, I mean, it's kind of material data, right? But it's also kind of GPU upload logic, right? So I don't know if this belongs here or not. But if I were to move it, I don't know where I'd move it to. The only thing we're really missing is the locations. All right, so let's go to the let's deal with the other issue first. So let's do material system config. Let's do struct renderer system state, and we're going to call this renderer, just renderer, that's fine. And let's do material system initialize after we set up the state pointer. Oh, we already had that here. Where do we put the, oh, it's down here. Okay. All right, well then in that case, this becomes really easy. All right, render frame number, that can go away. Okay, shut down event unregister, so that no longer exists here. That can go away. All right, I'm gonna skip these for now. In here, I'm gonna put state pointer renderer. Right, skip these for now. Same thing. State pointer renderer. Okay. This one's also going to be the same thing. State pointer renderer, but also instance resources release. That still takes a shader pointer, so we might actually want to do away with that and make that take a... We might want to make that take a ID instead, but I'm not going to change that right now. We'll skip over that for now. So here are the locations. Here's another place where we need this. So state pointer renderer. Here's another one. Okay, so we have a couple of these things that are no longer used in here. Let's get rid of those. Get rid of the warnings. Right, so now we have 13 errors left. And I think they're all going to be... what did I do here? What did I do? I'm not sure what I did there. Okay. Okay, so I think the rest of these are all these location things. Yes, it looks that way. Yep, okay. So... how do I want to handle this? So let's go back to acquire instance resources. This is specific for the texture map portion of this. So instance texture count. Sampler uniforms, kallocate. So we set up an array for that. We go through each one. Really? That texture's uniform location. So that's passed through there. That's the only thing that uses that. Where did that... shader instance uniform texture config. Uniform configs. So the only thing that this does, shader instance resources acquire. Does that property not even get used? Right, because this is uniform configs. So that's literally part of this object, which is passed in here. Uniform configs right there. So this is where that's actually used, right? Our uniform configs here. I don't actually see the... I don't see the uniform location being used here at all, actually. At least not yet. We might not actually need it. That would be neat. Bright Programmer, first time chat, welcome. How are you doing tonight? All right. New here, what properties does a material have? So, mostly right now, materials are primarily texture maps, but they're going to have a lot of other properties like metalness, emissive properties, things like that, right? Your typical PBR pipeline properties. So right now it's mostly texture maps is how those things are controlled, but we're also going to have like sliders on all those different values as well for like intensities and things like that. And then you'll also be able to apply like straight up colors if you want to, things like that. So we have, if we take a look at, let's see, we have material maps. So if we pull up this structure, our material has our texture maps right here, right? Various properties that we can sort of add to it, which is it's sort of, you can think of it as like freeform properties that we can add to it that have explicit meaning within the shader that we're using it for. So it can vary by the type of material. And then it also has an irradiance texture that can be explicitly set to it. Eventually we're going to have a diffuse color that you can add to it. Things like that, right? Also, Tokyo Spliff, are you the guy that does the OpenGL first-person shooter on YouTube? Is that you? Because if it is, your work is awesome, dude. I've been watching you for a while. Nice. The PBR stack, do I understand correctly that a material has a reference to which a shader should render it? Yeah. Yep. That is you. Awesome. Yes, I saw you were doing Vulkan recently. Yeah, that's pretty sweet. You've got some pretty good looking stuff on there for sure. I'm in the middle of a massive refactor right now, so unfortunately I've had to kind of like rip some things apart. Now I'm kind of trying to sew it back together, but it's gonna be worth it because a lot of this stuff like I kind of set up for like tutorial type of stuff in the beginning, which obviously came with tech debt, so I'm getting rid of that now. But yeah, that's awesome. I'm glad to see you here and welcome. right. So I don't even think. I think we're not even using. I don't think we're using the uniform location at all. So I wonder if I just kill that. If this is going to bleat about it anywhere. Feel that been doing a mammoth refactor also. It hurts, but will be worth it for both of us. Yes, exactly. Yeah. And the part of it that sucks is like I've been doing this refactor now for probably 10 streams. But my streams are only like a couple hours a piece, right? So it's probably not the most like entertaining content, but at the same time I know it's going to pay off for sure. Because it's going to make everything a lot more extensible. And a lot easier to work with and configurable. Because part of what I'm doing is actually putting a little bit more of an advanced render graph together, which is kind of what started this whole thing. And so a lot of this is the fallout from that, just having a sort of configurable render graph that I'm putting together. So like, we can come in here to our application config and set up like what kind of windows we want to start off with. All of our individual systems have their own kind of config too, where we can set up flags and stuff. We can define like what our plugins are, individual configuration for those. I'm still kind of stubbing that out. But then we also have this render graph config here, where I can set up what all the nodes are, their name and type, and then some configuration there. And each one of these things has like sources and sinks. Where you have sinks that accept a certain type of data and then sources that output a certain type of data, and you can just kind of plug them in together. And you can build out a render graph this way. And eventually you'll be able to do it graphically, which will generate this, which will translate back into that as well. So that's kind of what I'm doing all this refactoring for. It's a huge effort. There are times I've kicked myself for doing it. I'm like, man, why did I bite this off? But I know it'll be worth it eventually. All right. What is this bleating about? Config. Wait, we don't have config anymore? What the hell? Oh. Because I moved this to window creation. I don't have this anymore. Did we... That used to be in my initialize. Did we save that off by chance? I doubt we did. I don't think we did. Okay, so I may have to do that. Okay, crap. Not a huge deal. I don't know if I want to save off the whole config or maybe just certain aspects of it. Let's see, we got, well, all we have in there is flags for right now. I think I'll probably just store this in here as well. And then do context flags equals config flags. And then I'll have what I need. Window backend swap chain. Why is... Do we not have... We do have that. Oh, is this... Render backend interface. Oh, right. This should just be the window. We aren't passing the dimensions of this anymore. 10 refactoring streams so far, around 2 hours each. So you spend about 20 hours on refactoring, which is not so much, I think. Yes, I've also had to do some off camera though. But like the stuff I do off camera is like the way less interesting stuff. I'm not, it's like the redundant kind of tedious stuff. Okay, so I need to use the backend structure there. There we go. Okay. Which I guess you could argue some of this is kind of tedious too, but too few arguments. What am I missing here then? So we have the system state. The name. Oh, I'll bet it's... front end state name. Oh, we're not passing through the... What did I need that for? Logging, I guess? So I guess I could build one. I think I'm just going to go with that for right now. Doesn't really matter. Okay. That's deprecated. So that's just a warning. Don't care about that. This is like from all the crap I moved around. Some of the stuff just name changes and stuff like that. All right. So we have graphics command buffer doesn't exist here. What? I think this actually is current window. That's right. I have to reach all the way into this and go render state, backend state, image index. But where's... Oh, that's right. That's part of the window now. Right. I forgot about this. Okay, so I need to do... Let's grab this. Right, and this is k-window render a backend state. I guess we'll just call this backend state. And then I can just use that here. Right. Why is this? Now what doesn't it like? Oh. Derp. There. There we go. Big companies probably spend more time on refactoring their engines. Probably, yes, definitely they do. Especially when we're speaking about engines as a tool for creating games like Unity or Godot. Yeah, I can only imagine. Yeah, especially the huge proprietary ones, right? Okay, so... Oh, you know what? I think... Didn't I actually make a... I think I made a function for this, actually. Get current command buffer. That's what it was. Let's see, that should be back end. Yeah, so I should have done this up here. Way easier. Oh, we have ads. All right. So we got about a minute left on ads. All right. Ads are dead. Perfect. Falling stairs. Did you end up finding a new job? And if so, are you enjoying it? Yeah, so I actually went back to a previous job that I had. And yeah, it's fine, you know. It's good, it's reliable work, right? Can't really argue with that. So yeah, can't complain. Landed on my feet. So I'm fortunate to be there for sure. But thank you for asking. I appreciate that. All right. So speaking of that, actually, I do have to get up in the morning. So congrats. Thank you for that. I appreciate that. Because of that, I do have to get up in the morning for work. So I am going to have to close down the stream for tonight. We made some pretty decent headway. What I will do is I'll save my session so I know where to pick up tomorrow night's stream when we come on. Tomorrow night we'll be here around the same time, starting at 9 Eastern. Let me take a look at who we can raid. It's definitely gonna have to be like a raid and dash tonight, unfortunately. Just because, like I said, I have to get up in the morning, and I'm already actually over a little bit tonight. If I was doing this full time, I probably wouldn't obviously have to stop, but you know, it is what it is. Okay. I know who we can raid. This is a channel I don't think I've raided before, but it's a little bit of Unreal and C++ development. So we are going to raid Odd Oculus. And yeah, so I'll make sure to drop a a link for you guys over on the YouTube side so that you can kind of, if you want to check out his stream, you can. But yeah, thank you guys so much for being here. I really appreciate it. If you guys haven't already, toss me a follow. That helps me grow the channel. I really appreciate that a lot. Both on either side, right? But yeah, I appreciate you guys, and I'll see you here on the next stream. All right, see ya.